Hi everyone, it's Sorkin. Today we have a problem when we are given an array of integer nums and we need to return the length of the longest consecutive element sequence. So for example, in this case, we have three sequences. We have 1, 2, 3, 4. We have just 100 and we have 200 separately, right? So the longest consecutive element sequence is 4, so which we are returning here. The most important requirement for this problem is that an algorithm should run with the linear time complexity of n. Let's take this example that we have seen earlier and work on it. So what would be the brute force approach to solve this problem? For the brute force, we need to sort our input array and then we need to go over our array one more time and define the longest subsequence. But we cannot do that because even the best sorting algorithm would give us n log n time complexity. So, and by requirement, our time complexity should be linear. So we cannot do that. What is the another approach? Another approach is that we are using a set, and in the first step, what we do is we are going over our array and adding all elements to the set. And the time complexity of this operation is of n. In the next one, we are going over array one more time and finding all starting elements. So what's that mean? So for example, in this case, the starting element of the sequence 1, 2, 3, 4 is 1. So we have another starting point, which is 100, and another one is 200. So how we are going to do that? We are going to check in our set whether or not the previous element exists in the array. So what's that mean? So for example, we are going over our array one more time and finding a starting element. So for 4, does 4, in this case, we are checking that does 4 has the previous element, so which means that does our set contains 3. If it contains 3, then it means that our 4 cannot be starting point of our sequence, right? So in that case, we are skipping this element. And how about 100? Yes, 100 is the starting point, so we don't have 99. So in that case, we are the size of our longest subsequence in this case is just 1. So for the 200 minus 1 gives us 199. We don't have 199, so which means that 200 is the starting point. How about 1? We don't have 0, right? So which means that the 1 is the starting point. So starting from here, from 1, what we do is we are expanding our sequence. So we are expanding our sequence, so we are checking that if 2 is there, yes, 2 is there, so we have 1, our starting point, right? So we are expanding our sequence. Now we are checking that if 2 is in our set, yes, 2 is in our set. How about 3? 3 also in our set. So we are checking 4 also in our set, and the 5 is not. So the size of this sequence is equals to 4. And each step we are checking that our previous maximum sequence was 1 and our current maximum sequence is 4. And at each step we are updating our max sequence. So we are taking whatever the maximum of the max sequence, which was 1 earlier because of 100 and 200, and the current sequence, which is 4. So we are updating that to 4 and returning that. First thing that we do here, we are adding our array to the set, and the time complexity of this is of n. And we are also defining a variable max length that we are going to return. In the next step, we are going over our set, and we are checking that whether or not this num is the starting point. So we are checking that if num minus 1 exists in the set. So for example, for 4 minus 1 is 3. 3 is in the set, which means that it cannot be a starting point. And the next one, let's say that the 1 minus 1 is 0. 0 is not in the set, which means that the 1 is the starting point. And we are defining two variables: current num, which is in our case is 1, and the current length, which is 1 also. And we are expanding our subsequence and by checking that if the next element exists. So 1 plus 1, 2. If the 2 exists in the set, yes, in that case we are incrementing our current num and we are incrementing our current length. And once we exit this for loop, we are checking that if our current length is more than the maximum length, length. If it's more than that, then we are updating our maximum length and we are returning that. The time complexity of this is of n here with this for loop, and the while loop is also of n, because for each sequence, right, we are going to consider each element only once. So we are going over this sequence 1, 2, 3, 4 only once when we have 1, right? In case of 4, 3, and the 2, we are going to skip that sequence because they are not the starting point. And the space complexity is also of n because we are using set here. So first thing that we do here, we are creating a set, and we are going over our array and adding our elements to set. The time complexity of this is of n. In the next step, we are creating a variable max, and we are going over our set. And at each step, we are checking that if our current element is the starting point. If it's starting point, which means that if the set does not contain element prior to that, so for example, let's say that our starting point is 1, we are checking that if the 1 minus 1 0, if the 0 is in the set. If it's not in the set, which means that it's the starting point. So we are setting our current num to num. We are creating two variables, current num, which is equals to num, and the current max, which is equals to also 1. And then we are expanding our current sequence, so by checking that whether next element exists or not. So if the next element exists, so for example, let's say that for 1, right, 2, 3, 4, and so on, if they exist in our set, then we are expanding our current num and we are expanding our current max. And once we exit this while loop, we are checking that if our current max is more than our max. If it's more than that, then we are updating our max and we are returning that. The time complexity wise, the time complexity of adding to set is n, going over set is n, and that this while loop is also n, because for each scenario, for each element, we are going to consider only once each sequence. So for example, let's say that we have 1, 2, 3, 4, 5, and so on. So we are going to consider that only once when we have an element of 1, because for 3, 4, and 5, we are going to skip because they are not the starting point. So it's a 3 of n, and we can disregard the 3, and so our time complexity is of n, and the space complexity is also of n because we are using set here. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.